Welcome, everyone. See, we've got a critical mass. Thanks for your interest in information management systems. This is actually an initiative of the DFI Information Management Systems Committee. My name is Jamie Rosen, and I'm the current chair of that committee. And it's fitting that with an IMS webinar, our speaker today is actually the co-chairperson of this committee. Stick around for the end of the webinar. We'll tell you a little bit about the IMS committee and some of our current activities. I know several of you are committee members, and we appreciate your participation. So I assume you already know that as a participant, you'll have been muted, but there will be a Q&A session following the presentation. And you should see a question box somewhere on your control panel. Where you'll be able to type questions, and we'll do our best to get to every one of them. So great. As I said, our guest speaker today is vice chair of our committee. His name is Jeff Burton. And I've known Jeff for almost a decade and can tell you that he does excellent work. And he and I continue to learn a lot from each other in the world of drilling and grouting information management. Jeff is an engineer and a developer with ACT, Advanced Construction Techniques in Ontario. And he's been in a senior developer position on several prominent grouting projects, a few of which you doubtlessly have heard of if you're in that sector. And we're looking forward to learning from all of those experiences. So over to you, Jeff.
Thanks, Jamie. Thanks, everybody, for coming, and good afternoon. Thanks to the DFI for hosting the Information Management System webinar. This is exciting to be able to present to. And again, thanks, Jamie, for a good opening. Hopefully I can live up to it. So I just wanted to talk a little bit about me to start off, a little bit extra. I'm part of a software development team. And as part of a software development team, one of the things that we do is we have a meeting every day. And the meeting every day, we take notes, and then we have to distribute the notes, and it's quite repetitive. So one of the highlights of my week is to, on Fridays, we have what we call Meme Fridays. So we share memes, and it's on various subjects, and it's kind of fun. So I thought I'd let everybody else in on the fun and show a few of the memes that we have. So everybody does email, and I'm sure that this one can hit a note with everybody. I know it does with me. We're developers, so of course we have lots of programming related memes. So this one was a recent one that kind of hit me a certain way. It is kind of weird, but actually kind of true. So that was funny. But one of the other things to know about me is I'm doing the presentation from home. And at home we have four cats. So with this, I was like looking for a meme going, is there anything about this and meetings and stuff like that? And apparently there's a meme for that too. So here's one that I thought was kind of funny and why I have a virtual background. So anyways, let's hop in. Okay. So today we're going to be talking about information management systems, and we're going to get into some of the under the hood stuff about telemetry and talk about some real world experiences about measurement while drilling. So to start out, we're going to have like 3 acts. We're going to talk about information management systems and what they are, some of the good stuff about them, and some of the components of them, just to give you an overview and so you can get your feet wet about knowing what this is. I don't want to assume everybody comes from the same spot. Next up, we're going to talk about telemetry, how we connect from the sensor all the way to the system, and the equipment that's used for doing all of that, and some different scenarios that we get into. It's not going to be a full broad in-depth study of it. It's going to be giving you some real world what works and what doesn't information. Lastly, we're going to talk about measurement while drilling. We're going to talk about what it is and the purpose of it, talk about the parameters and data surrounding it, and the good and the bad there. And then we're going to talk about some lessons learned and how best to be successful at measurement while drilling on a project. So first up, what is an information management system? Don't usually read a lot, but there's some places that require that, so I'll do that here. So an information management system is a centralized computer system that takes in data from multiple sources for the purpose of storage, organization, quality control, and visualization for the life of a construction project. So that is kind of a big definition, but when you look at it from the perspective of projects and what's on a project, it comes into focus. So these sorts of systems, they span in size. So you could have a small system like the one I'm showing here, which has different equipment on the site. You might have some some equipment that you bring along that you've developed within your company, or you could have equipment that's you bring like a drill or something like that, as well as some other kind of manual data you bring to the system. And you can bring all that to a central database and repository, which could be a laptop, and display that information, share it, having reporting, all of those sorts of things in a single place. That can scale up to very large systems that have all kinds of components. So the small components that I talked about there, we could encapsulate that in like a data monitoring system. Then you have other things that would be involved, like drill logs, optical televiewers, instrumentation systems, all of those sorts of things, which feed into maybe a centralized database system that would be in the cloud. And it would have more of a repository for the data, like a database, and then a file share, a GIS component, all the bells and whistles. Connected to that with clients, you could have a control room and have all kinds of computer monitoring there where you could be monitoring the system or like the operations going on, or you could be monitoring instrumentation. And then off of that, even more clients can be connected either through the web or even if it's connected to the local system for whatever applications that they're running. So in a nutshell, that's what they are, and gives you the full spectrum of what information management systems can do. What are the benefits of them? One thing that I like to think about when I'm talking about information management systems that I deal with is one truth. So what that means is that when you have data that is coming in from different places, you want it to, when you have it in a central location and share it from that central location, that data is validated, it's quality controlled, and then when it's shared, you're seeing one piece of data in many different areas, but it's that one piece of data. So the truth is what that data says, as opposed to maybe having different places where all this data is, and then trying to compare it to each other and not knowing, okay, which one's the right one, which one isn't. So that's why we say one truth. And I think that kind of encapsulates the main benefit of these systems. Talking about data a little bit, when I talk about data, these information systems, there can be data from all different sources and different formats and things. That's why we call it heterogeneous. It's not the same, right? And they come into one spot and they can be, looked at or analyzed or whatever from a common context of the project. So you can have where you'd have these things from different places and you wouldn't always be able to analyze them together. When you bring them together and maybe report on them, bring it for the different data in one place, you can say, oh, well, that correlates with that, and you can run statistical analysis on them. These are one of the benefits that you have there. Another benefit is from these systems is that the data can be shared with all the project stakeholders, and there's a number of them. This is just a kind of an encapsulation of them. One of the main ones, the owners, right? They're paying for it, so they want the data to be right. So they want to have confidence in the data. Some of the gains that they could have is maybe from the data, they can see areas within the schedule where they can gain efficiencies. And so the schedule will be improved. At the end of the day, or even while the project is going on, they get a complete as-built of what's going on, or of the project. They get the data as-built as well as the visual or the drawing as-built as at the end of the day, with the data enhancing or augmenting the drawing. And then they also have confidence that the data that they are seeing has been validated, it's been quality controlled, and that that this data is right. It's not something that they have to be suspicious of. Engineers, designers, consultants, contractors, they like the visualization aspect of it. They like to be able to see visually how this data is relating to each other, and even like with GIS and other things, how the geospatial relationship of the data is. So these are important components of these systems. As the data comes in, they can see the feedback on their design. Is this working? Are we, for grouting projects, are we, slowing down the seepage somehow? And so they can get that as they go on the project, so they can correct course maybe in the middle. Progress of the project visually, or even from the data, they can see, oh, how many holes have I done drilled? How many do I have to drill? Things like that. And with the data coming in from the field almost in real time, they can see how many quantities they've been using, or time they spent. And so it can give them an idea of, okay, how much have we used? Do we need to reorder some stuff, or even use the quantities for billing purposes? Suppliers, service providers, they get the equipment they supply, they can use the data to see how it's performing. Where is production rates? Is it needing replacing soon? Things like that. So they can glean value from the data where they might not have been able to before. And all of the stakeholders can get good engagement through the visualizations. I'll show you a little bit later some of these visualizations, but they are really good for folks who don't know a lot about it to be able to see what you're doing. All the stakeholders can also know that you're going to get a better product in your project completion. They know that it's quality. You've been doing your due diligence all the way through, and the product at the end is really good. And as well, when you have your eye to safety, you can use the data to make sure that you're doing things safely. Let's say instrumentation systems and things like that. It's very important. So at the end of the day, you can say that information management system promotes safety, quality, durability, and sustainability of the deep foundation work that we're performing. So that's the benefits. So let's talk a little bit about the components. I want to say thank you to Jamie and GeoSyntech for providing this cool animation graphic. So you can see in here that in the top part, we have our inputs into the storage system of the information management system. Then you have your storage component of that. And then at the end of the day, you have your outputs and usage of the data. And I like to call these things, the one part of this is data producers, the things that create the data that go into the database. And these things we'll get into a little bit after this. And then you have your data consumers. Those are the things or the applications that take in the data or use the data for some purpose. Then you have your visualization component, which is becoming more and more key to these projects every day. For me personally, I believe visualization is one of the top things that you can employ in an information management system, because it just brings everything together in a concise way that people don't have to put a lot of thought to. It's just there. Data repositories, there wouldn't be an information management system without these data repositories. That's this middle section. That's the databases, the document stores or the file stores, those sorts of things. Those are very key to these systems and being able to be able to put the information out there. And one of the last ones is reporting. Again, any good system has good reporting. So these are the kind of the outputs or the product of the system is reporting. And then lastly is document management. So with with these projects, documents are huge. There's lots and lots and lots of documents. And so sometimes there's requirements of what documents are required, which ones need to be produced on a daily, a weekly basis, that sort of thing. And it's important to make sure that all of the boxes are checked and all the documents are taken care of. So if we have software that helps you with that, it can just make things more efficient, easier on the folks implementing or carrying out the project. So let's talk about data producers. That graphic, you can see that the information management system is in the middle, and all of these data producers feed into that system. So in the beginning or at the top left, you can see custom equipment. And And so custom equipment would be anything that maybe contractors or others bring to the website that is kind of their special equipment that they bring in. So the data that they produce can come into an information management system. Next, you'd have manufactured equipment. So those would be drill rigs like you see here, maybe hydro mills, any other kind of deep soil mixing, jet grouting, any of those sorts of things. Those piles, those things create data. And so you can get that data off those equipment and bring it into the system for analysis and associating it with different aspects of the project. We'll talk about measurement while drilling later, which is one of these data sets. Processing plants. Lots of projects have processing plants. My experience is from the drilling and grouting world, so we use grout plants fairly regularly. So that's what this is. But there's also the plants that are maybe for soil retaining the soil from a hydromill process or something like that. Manual data, anything that you do out in the field that you might want to observe, you can put into a tablet, or you could even have it on a piece of paper. That kind of information can be digitized, brought back into the system, and then related to other things. Other times you could do underground surveys. So there would be like your optical televiewer and your acoustic. And what they do is you can bring that information into the system and relate it to grout holes and grouting, or sorry, drill hole grouting, or any of those other things. Underground surveys. Sorry, I got off track. That would just, okay, there we go. Project documents. So there are lots of documents, as I was saying before, are related to these systems. So there has to be a way of retaining that, organizing it, and presenting it in a way that people can access it within a click or two. So that's one of the goals of these systems, is make the data available and right away. And lastly, any of the maps, CAD drawings, historical drawings, those sorts of things, those can also be part of these information management systems, so that you have a full data set of what the project entails, all the data associated with it, and then you can bring it together in a concise manner. Next, we have the data consumers. So these are on the other side of it. So once the data is in the system, these are the things that use that data. One of the ones that I'm near and dear with are the operations monitoring and control user interface. So on the top left, you can see there a trend control, as well as, sorry, I guess I didn't use enough duct tape. Sorry. So you have the trends, as well as the you can see the project as the 3D there, and you can see the colorization as you go through the project. It shows how you're doing. So it's very important to display that as you're going. GIS. So there's a bunch of different apps for GIS, and that's they take in the data and can show you in many different formats graphically what's going on. Very powerful tool. Data reporting, though, that's your application that is essential. There's always reports that are needed to take all of these data and be able to provide it in a manner that people can see, can become part of the project record, and a way of analyzing. So you can, for grouting projects, you can see your closure analyses and things like that. All of this data comes out of the system and provides value at the end of the day. Some of the newer stuff that's coming into these systems is quality control data. So this can be both a producer and a consumer, but as you do quality control on samples, let's say grout samples or what have you, that information can be input into the system, but can also be brought out as a result. So you can see, you can tie quality control data to operations. So if you have a grout stage that you've done and you put a certain batch of concrete into it, you have tested that batch. So later on, you can maybe go back and say, okay, what was the results of the quality test for that grout stage, and you can relate it back. So these are some powerful things now that when you're bringing this data from different sources together, you can relate it and get more information out of it. Document management, as I was talking about before, now that we have this in one place with the information management system, we can now tie things to operations. So let's say an operation, it's a requirement of the project that when you finish a drill operation, you need to create 4 documents. These document management systems now can say, okay, drill stage is done. Where the system is now owed 4 documents, and it can show that those 4 documents are outstanding until they've been uploaded. And then when they're uploaded, then the requirement or it goes away that they're needed. So you can keep track of what it is that you're doing document wise, and it has a way of maybe figuring out, are you adhering to your naming convention? Very powerful application. And lastly, you can have any other number of applications. You can have a standard way of transferring the data to them. It's just your imagination, and the sky's the limit, really. And there's a way of doing that. Digs that's out there. Won't get into that now, but there's standardized ways of transferring data through different protocols. All right. So next, we'll get on to a cool part. We'll get on to visualization. So something very new that's come together is the 3D digital twin. And that is having a project and putting the data into a spatial relationship and making a 3D model of it and showing that in real time as the project goes on. So this is very, very good, because everything, when I talk about things underground, I talk about as soon as something goes an inch below your feet, you have to rely on your spatial understanding of, where things are going and where they end up to be able to understand how the project is progressing. When you add in, 300, 800 holes with 10 stages each and different operations, that becomes a seriously daunting task to be able to understand all that. When you can put that into a visualization with 3D, and you can zoom in on it, you can orbit it, you can add other aspects like tunnels or geologic features like faults, then the power of the 3D really comes into play. So you can understand exactly what's happening and why your stage is taking a lot of grout. Oh wait, that fault goes through that spot. Oh, okay, I get it. So 3D digital twins are very important to the understanding of these projects and how the value and the value of it comes through. The other part of it for visualization is real-time monitoring. You can be getting data from the field in real time and visualizing that in a control room or on a laptop, so you can see immediately how the operation is progressing. So on this one, this is something from IntelliSystem for grouting. You can see the digital values on the left and the flow, the trends on the right, and so you can see how they have been responding over time. And you can even see on the left-hand side of the trend there that there was a mix change at one point. So these things give you added value as you're trying to monitor your operations and make sure that you're doing what your intents are. GIS is another huge visualization component of these systems, and they have different parts. You can have a desktop GIS, web GIS, drawings, those sorts of things, and it brings the data to a geospatial visual understanding, which is very powerful because it can take data from all different sources and put it together with a geographical location, and you can glean a lot more information out of it. Dashboards are another really good component of these systems. They kind of give you an idea of where you're at. So on the bottom there, you can see like a plan view and a profile view. And I've zoomed out the dashboard component, and you can see that these little widgets, I guess you could call it, show you different aspects of how you're progressing. So you get number of holes drilled versus the number that you have to drill. And then in the bottom there, you can see that how the closure is going. So you can see that on the primary series of holes, there's a lot of grout been injected, but on the tertiary series of holes, a little bit. So you can see you're getting decent closure along as your project has been progressing of the 105 holes already. Lastly is historical trends. So this is taking your trend data that you saw before in real time, but that now it's in a report that can become part of the permanent project record. So these trend lines have all been produced by monitoring sensors. And the way that we get the sensor information into the system is through telemetry. So that was the discussion on information management systems. So we're going to get down into telemetry a little bit. A couple things here about telemetry is that this is going to be something that we've developed over the years as to what works, and what we find is work for the projects we're on. It's not a short course. It's meant to get really deep into protocols or anything. We're just going to talk about how we get information from the sensor into the systems and the things that we find are work best. So the general definition of telemetry is the in situ collection of measurements or other data at remote points and their automatic transmission to receiving equipment through telecommunication for monitoring. So that's kind of a general idea, and Google was very helpful in giving me that. But if you want to relate that to information systems and how it kind of works on the ground, is that telemetry is the acquisition of sensor readings and transmitting them back to a central location for real-time monitoring and storage. So if you look up at the top right, there is a sensor, and telemetry is the process of getting that information from the sensor, the readings from the sensor, into the information management system. So a few components that I'm going to talk about today about these is the equipment that's used to get the sensor readings, and how to connect the sensors all the way to the system. And then we're going to talk about a couple scenarios. There's two plain scenarios that I've seen that we go through to do telemetry. And then last is when you get it to the system, how to receive it and process it. First up, the equipment. So how exactly do we acquire a sensor reading? So you can see here on the right that there's a bunch of sensors potentially for something that you're measuring. This would be a grout cart, so there'd be a bunch of sensors that would be associated with that. How do we get that information from these sensors? So first off, we have to understand that they're analog values that we're reading, and so that is in the format of 4 to 20 milliamp electrical signals or 0 to 10 volts. Primarily, we use 4 to 20 milliamp signals because they can be transmitted a long way, like over a long wire, without any degradation in the reading. So when you see 4, you get 4, and or 15 or whatever it is. It's not going to be like over 100 feet, you're going to get 9.6, and over more, it degrade. It's just no, 4 is 4, and that's it, or 9 is 9, whatever. So that's what sensors are. And so the equipment that we use to connect to the sensors and to kind of read their values, there's different kind of flavors, if you will, that have developed over the years. First up, and ones that have been traditionally used, like 15, 20 years ago, even today, it just depends on what you're doing, are PLCs. Those are programmable logic controllers. You can connect wire sensors directly into them, and they have computers on them, very powerful applications that run, and you can do all kinds of things with them. And so when you use them, these PLCs, you have to use specialized software to get those readings off of them and into like an information management system. These PLCs have in the past been expensive. The software has been expensive, and there's a little bit rigid to work with, but they have their place. People use them and they're definitely useful, especially on like larger piece of equipment like drill rigs and things like that, or hydro mills, definitely used. Ones that we tend to use nowadays, they're called DACs. They're data acquisition units. They're much simpler and smaller. You wire directly into them for the sensors, and they have little computers on them and little, specialized software that their purpose only is to read the values and give them back to whoever's interested. So they on these little devices, they might have a little web server, and we call a web API application programming interface that you just give it a little. They have an IP address, so you have an IP address like web address, and you send that out, and then you get the values back. That's simple. Nowadays, with the newer ones, they can even push messages to your system, so you don't have to pull them. They just send it out, and as long as you're subscribed to that message, you'll get it, and then you can deal with it. Next up would be data loggers. These are more used for instrumentation systems, but they can do relatively close to real time information gathering and sending. And those are similar to PLCs, but they're very much used similar to a DAC. You get the information and you store it, and you can also send it out in a short period of time. Again, you need specialized software to access them, but they're more suited to geotechnical work. And then you have the proprietary systems. And by proprietary, I just mean that people build drills or hydro mills, and they have their own way of gathering their sensor information. So you don't get directly on the sensor. You kind of are abstracted away from it, and then you just connect to the proprietary software or whatever they have, and you get it from them, much like a DAC. So you get it from an API for a web server, push messages, or even CAN bus. So these drills or whatever would send this information around on a little bus system for their computer, and they would allow you to tap into this CAN bus and read the messages directly from there without any kind of intermediary. So part of the secret sauce that makes this all happen for information management system is using the TCP/IP networking protocol. And this is the kind of the encapsulating protocol that's used so that you can send this information along a network. We'll talk about that in a little bit, but when you're talking about reading sensors and underlying things, there's these protocols that work underneath the hood, and then you have to send that information some way. It's like a text message almost. And so you use TCP/IP to send it along a network. So talking about networks, that's connectivity. And that is, how do we get the sensor readings from the source to the destination, which would be an information management system? So again, talking about TCP/IP networking is that the reason that it's used is that it's ubiquitous. It is used everywhere. There is an infinite amount of equipment that's out there, both commercial, industrial, that has been very much honed and optimized for what we do, or for moving information around. And by utilizing this, then you don't have to go to different sources of specialization. If you have decent networking skills, then you can use this equipment. So that's why we use it. It is everywhere, and it's not difficult to pick up. And most people understand it because that's what computers work on. That's what we're using right now to have this webinar. So some of the methodologies that we use for connectivity. Number one, and tried and true, it's been around forever, is wireline. So these are your Ethernet cables. It's very reliable. You connect a cable to one place to another, as long as it's not, severed, you're going to have transmission. So it's a very good option. Just a problem if you have mobile equipment, because if you have mobile equipment, you're going to have to unplug and plug and unplug and plug, depending on, how much you're moving. The one that we use the most is wireless. And wireless is just more efficient, easy to work with. And so it's just the way that we go. You can use a combination of both for more reliability, but the wireless is pretty much the way to go for mobile equipment. What we use mostly is a Wi-Fi type of network, and it's 900 megahertz, 2.4 gigahertz, or 5 gigahertz. And because we want it to be reliable, it can be either using um, spread spectrum, frequency hopping radios, or it can be using a mesh where it uses different equipment to transmit messages along the way till it finally gets to the gateway and back to your system. Other things that have been used for, or that can be used for wireless is cellular. There is a latency to wireless. It doesn't exactly get there. There's a second or two latency. So depending on your real-time needs, that might not be perfect. And satellites have been used in really remote locations, but your latency issue is just even more with those for traditional satellite data. An exciting one that's come online recently that I'm kind of looking forward to using is Starlink. So that's a low latency satellite network. Thanks, Elon. And it's supposed to be just as good as using your network at home. So with that, the possibility is you could have a control room that's miles away from the actual operations, but you wouldn't see any difference. So you wouldn't have to lay like a fiber line or anything. You could just use Starlink. Um, but like I said in the beginning, you can be combining the wireless and the wireline together to make it more reliable. So if you have conditions where the wireless isn't working, you can go to wireline and you don't have any downtime. You can just continue your operations, and if there's a problem with wireless, fix that or wait for the weather to clear and it gets better. Okay, let's talk scenarios. So there's two scenarios that really get into for telemetry. Number one is you connect directly to the sensor. So this is commonly something that you put into place if you have the equipment yourself, and you're putting that together. So I'm going to talk about the things that you have to think about or do to make that work. And then there's what I call rig aggregation. So the rig, so let's say it's a drill rig or hydromill, they read all the sensor values and put it into a central location on the rig, and then you have to get that information off. And I'll talk about how that happens typically. Okay, so direct sensor connection. So to make this happen, you have to know about the sensors involved and their specifications. So if you remember, I talked about 4 to 20 milliamp signals. So when I talk about their specifications, each sensor will have a range. So let's say you're talking about a flow meter. A flow meter, let's say it goes from 0 to 50 gallons. You would have to know that that 0 value will relate to the 4 milliamps reading. And then the 50-gallon level or the top end will relate to the 20 milliamp reading. So now that you have those things, you can relate them through the linear equation as to, okay, if I get so many milliamps, 10 milliamps, well, that means a certain amount of flow. So that's why I said you need to know that to be able to put this in place. Once you understand, your sensors, what they're putting out, 420 milliamps or whatever, you need to design your electrical circuits so that you can implement or include the sensors and bring it to a termination point, which would be reading the sensor values. And that would be your DAC gear, some sort of data acquisition gear that you would read the sensor value and be able to then put that out for transmission back to the central system. Again, so I just said data transfer method. How are you going to get, once you have that information into your DAC, how are you going to get it back to the central system? So you have to figure that out. And that's, wireless, wireline, all that sort of thing. And so then what network are you going to use? Like I just said, it has to be connected to the hub, the central hub, the information management system. How are you going to get that back? Okay, so moving on to rig aggregation. So as I was saying before, the sensor readings and conversions to engineering values, that's done on the rig. So they have some sort of gear on there that's doing all that work. And because the rig usually has their own controls and ways of showing the operator what's going on. So that's all kind of happening. So now that you know the data is on there, you have to know, okay, what's it going to be like um, for me to get it off, or for the system to get it off? So first of all, you need to know what data it's going to make available to you. So what sensor data, if there's 4 sensors or whatever, you need to know what they are, okay? And so the other thing you're going to need to know about these sensor values is what units are they? Because the units that might be on the rig they might be using might not typically be the standard units you're using within your project. So there might have to be something done on that when it gets to your system. So units are important. The other thing is going to be important is, okay, when they transmit that data or the data package to me, what's that going to be? What kind of formats are going to be in? Is it going to be a CSV file? Is it going to be a JSON format, XML? What's that going to be? So that when you get it, you know how you can decipher it. And lastly, how often are they going to be sending it to me? Or am I going to be grabbing it? And can their rig give me the data in that frequency? So some things you got to work out before you can actually interact with it. You have to establish a method of data transfer. So how do you get it off there? Like I just mentioned, is it a web API that you're going to be accessing? Are they going to be sending it to you on a certain frequency? You have to know that. Then you have to know how you're going to connect the rig to the network. So for us, we do have drill rigs through measurement while drilling, and we do it wirelessly. So we had to figure out, okay, how are we going to get these rigs connected to our network? Because they don't come that way. So we have to, create a little connection package enclosure for them so we can connect them up with our gear. And lastly, how how are we going to transmit it to the central hub? So once you get all that together, the last step is getting the data back to the central hub. So those are the scenarios, and hopefully gives a good idea of the different ways of transmission and telemetry, and gives you some good insight as to how we do that. So once we get the data out and we get it back, get it coming to the central location, what do we do with it? Okay, so I know that's not specifically part of telemetry, but it's very important to information management systems to work with the data from the field. So the first component is receiving. So there needs to be some software on the information management system that can receive the data in real time. And so it performs this intake task where it says, okay, I got this data. Now I put it somewhere. I do something with it. I inform something to be able to take it to the next step. So that's a very important component. Next is once we have it and it's been handed off, this data is usually in some sort of text format, like I was saying, CSV or JSON or whatever. We need to take the data and decompile it into values and other attributes like units to be able to use it within our system. It's important to be able to, know what drill rig it is, know that it's a pressure and, those sorts of things. So that's the parsing component of it. So next is if the values are coming in raw, like in 4 to 20 milliamp, we have to convert them. Have to convert them to engineering values so that it's something that's readable by a human being within the system. 4 to 20 milliamp values don't really mean anything to anybody until it's into an engineering value. Or the other possibility is you get an engineering value, let's say from a drill rig, that's in the wrong units. So if I want to look at something in US gallons, but it's in liters, I need to convert that. So that has to happen within the system before the information is made kind of public. Once we have it converted and all that, then it needs to be stored with a timestamp and put into the database for historical reasons and for an analysis later. So that's another task that has to happen. And lastly, is the dissemination portion. So when we bring in the data, or once the data is available, we need to be able to either push it out to all the clients waiting and they're subscribed to the data in some way, or we can put it into a easy to access central location that the clients can be polling to see if any new values come in. So basically it's saying, okay, in this one area, here's the data. Here's the place where you get the data, and the clients go, do you have new data? Do you have new data? And then once new data comes in, they're like, oh, new data. And then they can do something with it. Okay. So that is telemetry. And as I was talking about earlier, one of the big components of telemetry that we've been putting into place is measurement while drilling. So that's the next part that I'll be talking about. All right. So hopefully we learned a lot about telemetry, but measurement while drilling is something new and something that's been put into play recently on these projects. So uh, lots of questions about it. People have interest in it. So let's go through it. So measurement while drilling, I'm going to talk about what it is first. And it's at its core, it's measuring various parameters while you're drilling a borehole. So it's, that is the essence of it. And what the way why it's important, or what's the kind of the secret sauce here, is that each measurement is tied to a depth of the tooling so that you can get information about your drilling at depth while the drilling is proceeding, which is important. Today, I'm only going to be talking, the measurement while drilling I'm talking about is only to do with drill rig parameters. It's not the downhole parameters that you would get maybe in the oil industry or for directional drilling. This is specifically for rock drilling on deep foundation projects. And this is only the parameters that you can measure on the drill rig itself. Measurements are taken continuously through the electronic sensors. So when you're doing an operation, the system is always recording every parameter all the time, whether you're advancing or not. It takes it in and it records it. And that will come into play a little bit later, but that, it's important to have that, but it also creates some stick handling you have to do when you have lots of data coming in. As I said, the readings are recorded locally on the drills primarily. So there's little computers on the drill that have interfaces to the operators, and that's what does the work of recording the information. New nowadays is that we have put into place, and I think this is happening in other places, that readings can also be transmitted to an information management system in real time. That's what the telemetry part was all about. And so we can get 1 sample per second readings from a drill rig now, and we can display that in real time as we're doing these operations. So that's why I just said we can visualize it in real time. Okay. So what is the purpose of measurement while drilling? One of the main purposes that people use, especially if they're doing exploratory work for a project location, is that they can develop a geological model from the information gathered from a drill rig. So how that happens is they can relate these drilling parameters, whatever they are, to geology because of the depth component. If people are going down and they get certain information back from the drill parameters, they can relate it as to what kind of ground it is, and if they're experiencing different conditions. One of the other things that they can show or get information back is an unexpected response. So if they have like a time of high penetration rate, let's say, they can say, well, okay, well, that's soft rock we weren't expecting, or something like that. Or if they lose their water, they get a lot of water loss. That might be a place of a void. These kind of things give information about the geology that you're going through that you might not know, or you wouldn't know until you drilled a hole. One of the other calculated parameters that come from measurement while, or allow you to arrive at from measurement while drilling a specific energy, which is defined as the work done to excavate a unit volume of rock. And that encapsulates a lot of the parameters that are used during, or parameters that you get back from measurement while drilling. And don't get into it much. I haven't used it much, but there are textbooks and papers and stuff that are on it. And I encourage you to go take a look if you're more interested in it. But that is something that is gleaned from the measurement while drilling process. Another purpose for it would be to evaluate the performance and the efficiency of the drilling operation. So you can be evaluating the drill rigs or the tooling or even the drill operators themselves. So it's can give a lot of value and a lot of information during your drilling operations. Okay, so let's talk about the parameters a little bit. Mentioned them already a little bit. Depth, which is the key component, because if you didn't have depth, the other information wouldn't make a lot of difference. So the other ones are penetration rate. That's how fast the drill tooling is going through the geology. Rotation, that's how fast are the RPMs of the drill tooling as it's advancing. Torque, that's the amount of force that's required to spin the drill string as it's going down. And then the down thrust, that's the force of the drill string, or the drill pushing on the drill string to make it go forward. Some other ones that are utilized or that we get back from the drill rig are water pressure. So that's the water pressure going into the drill ring, maybe to run a hammer drill. And things like that. Then we have how much water is going in, so the flow of water going into the drill string. And one of the newer ones that we put into place is the water coming out, which you can then relate to the geology and how much percentage loss of water is going into that area, so that maybe you can get some information about what kind of rock you have, or if you get no water return at all, which gives you even more information. So you see a little table there just showing you a little sample of the information that we get back, and you can see how visualization is kind of important, because just looking at those numbers and think of a couple thousand records, how it would be hard to get anything out of it without visualization. So visualization, here's an example of some visualizations that are associated with my measurement while drilling. On the left is a screen from a Jean Lutz Dialog MX2, and you can see that this is what the drillers would see when they're drilling. So it gives the information of all the parameters on the left, the digital values, and then on the right it gives some of the trend lines for a couple of the parameters that are being measured. So you get tool pressure, rotation, injection flow. Those sorts of parameters they're giving the trend there. And on the top, you see a little green bar. That's the penetration rate. So it's almost like an indicator. The bar is full, you get a higher penetration rate. Low, if it's smaller, then it's a lower penetration rate. On the right, you can see that that's a real-time trend from IntelliSystem, and this is where you can see when you put the drill trends together at the same depth, you can glean a little bit of information, or you can glean more information out of it. So you can see there's some spikes there that show something happened across the whole drill. And depending on what you're trying to analyze or determine, those things could mean something to you. And as the values move with each other, you can see the correlation. Okay, as the rotation goes up, then the penetration rate goes up, or whatever. So very important to put those things together in one visualization to be able to see on the whole how the drill is doing. My throat's getting a little dry. Okay. One of the more important aspects to measurement while drilling, if you're putting the data into an information management system, is the data volume and the concept of crescent depth. So one important thing to remember is the measurement while drilling data is constantly being recorded and transmitted. So as an operation goes ahead, all the information comes back to the system, even if the drill is not advancing. If it's a lot of times with drilling, the drill head will go up for a little bit, will come back down for advancement, those sorts of things. So all that data is being recorded, but only the crescent depth is the one that is being used to create the trends like you see on the right. And what crescent depth is as the tooling goes down, it makes a new depth, okay, a new deeper depth. That at that point, that that piece of information is recorded as a crescent depth or a new depth, and it's charted. Any other depth that might be above that after that point is not made part of the trend. So what we found is of all the data that we record for measurement while drilling, only 10% of those data records are being used to create these trends. Okay. So what that means is that you get a huge amount of data, and that can be a problem, whether it's in the database or in files, because it takes up space. It is a data volume that you have to deal with. If it's a large amount of data in a database, it can slow down the database, require you to make changes to make things more efficient. So from our um, working with this, we get millions and millions of records that we we record in the database, but we don't use. So that that becomes a value proposition. What do you do with that? Um, when we have a downstage drilling program, which is you create a stage, then you pull your drilling out, then you do some work on that stage, and then you put your drilling back in to make a new stage. There's tons and tons and tons of ins and outs. So again, when you're doing that, it's creating lots and lots of information, and the crescent depths are a very small component of the actual data. So what you can do is you can reduce the data by only keeping the crescent depth records. And you don't get rid of all that other data. You just move it to a different database or a different place where it's kind of like a historical archive. So if you want to look back at all of the records, you can, but it's not kind of in your active database. It's not taking up room and slowing things down. So those are some of the findings that we had when we've used measurement while drilling. Okay, so those are some of the aspects of measurement while drilling and what we found. But now that we've talked about that, I want to talk about how, if you want to implement a successful measurement while drilling program, some of the things that you would want to consider doing to make it successful. So first off would be to know the technical details of each sensor and why it's important. Because if you don't, everything has a priority, right? If you don't do that, then all sensors are going to come in and you're going to be, oh, this one is, what does this mean? What does that mean? You want to sit down and understand it from the beginning so that you can analyze it properly when you're actually doing the drilling. Um, because of the complex network or complex nature of it, you want to make sure that things are done properly when you install the sensors, and and know that things are going to break on drills. They just do, and you want to minimize that as much as possible. So take the time to install them properly, make sure they're protected, so that you have the greatest chance of success when you're actually doing the work. Uh, that being said, there is a balance. You have this rugged environment that you're drilling with, but you also have these delicate sensors and communications gear that you have on the drill. So you have to strike a balance to see how you can do that properly without, you know, having things break down too often. So it is a little bit of a tricky area. Next up would be data transfer. So recommend, especially for drills, wireless. But you want to make sure that your network is robust, meaning that the data will get to its intended location every time. What that means is that you have to, with wireless, you have to eliminate any line of sight issues. Wireless radios require line of sight. So if you don't have that, because drills have these huge masts on them and things like that, you have to employ a way to deal with that. You could have multiple repeater points, or you could have a mesh network where you transmit the data through other equipment, things like that. But it can be done. You just have to plan for it. And then the last one is to understand weather effects. Weather affects wireless, and it just does. So if it's raining or snowing or fog, it's going to degrade the wireless signal. So you have to understand that and have a strategy for it, which could be the next one. So if you can't transfer the data wirelessly or wired, you might have to do it manually. So manual transfer of data, at least from our experiences, you have to put the data onto a USB data stick and then bring it back to your system and then be able to upload it into your system, which requires you to kind of take the data off the stick, transform it to your kind of data set, and then get it into the database. That can be a cumbersome process. So plan for an efficient workflow. Figure that out from the beginning so that when the time comes, you know what to do. You have the things in place to be able to upload it quickly. All right. Another aspect of having a good measurement while drilling program is training. So there's one of the aspects of the training is to train the drillers. And a good thing for them to know is why you're doing it. They need to know how the drilling operation relates to the measurement while drilling and why you're getting the information back and how to operate the measurement while drilling gear, because they're the ones who actually do it and do the drilling, but they're also the ones who make sure the data coming in is proper in a way. So they have to zero out their drills when they're starting, that sort of thing. So it's important for them to know it and to know why they're doing it so that they can put importance on it too. There's a measurement while drilling console on all drills, and they have to know how to operate that and all the intricacies about that. Next training is the control room personnel, and those are the folks that are manning the drills, where to go and to do the operations, and they need to know the end-to-end data flow of the drilling information. So how it's coming off of the drill and how it's getting into the information management system, so that they can know when they're seeing something within their screens and during the operation of what the source, if it's not right, what the source of it might be, or how that it's not right. So that maybe the things can be modified so that the information coming back is corrected. And one of the key components to a successful measurement while drilling program is to define the purpose of the program. So why are we collecting this data? One of the biggest ones and most common ones is you want to get a geologic interpretation. That means that if you're putting holes in the ground, you can get some information back from those holes. So that is about the geology. And that's one of the key components, or the things that people like to have measurement while drilling for. Another thing is you can see how drills are performing, drillers are doing, as well as how is the tooling doing. Okay. So some of the real world challenges that we have found while we do this. Number one, I'll give a little background or context in the project that we applied this on. We had to put wireless connectivity into place for 4 different drills, 2 different type of drills. which was somewhat of a challenge. We had rugged terrain, meaning that there was a lot of elevation changes in that, and our control room was a kilometer away from the actual work site. So we had to, we didn't have a line of sight, so we had to figure out another way to get the data back there. We did small diameter diamond drilling, which meant that this is a different kind of typical application for measurement while drilling, which is usually larger diameter holes or exploratory holes. We were doing production drilling on a drilling and grouting project. And we were also doing downstage drilling. So we could be in and out of a hole 30 times, maybe more. So that, created a data issue like I was talking about. So we had a very wet physical environment, and we found that it was hard to make electronics work properly if we didn't protect it properly. So that took extra expense, extra time. And then when we were doing wireless communication, as I mentioned earlier, the fog and the precipitation, it created problems with the wireless. So we had to figure out a way to mitigate that. And we ended up going with a wireline solution as a backup. So when things got bad for the wireless system, then we could go right to the wired and we could keep our efficiencies up. And when we did that, though, when we had to stop and change over, you couldn't do things like as if you were doing drilling just without measurement while drilling. It does affect the efficiency of drilling operations to some degree. So you have to kind of take that into account when you want to set these things up. All right. So another challenge that we have with the manual retrieval of the data, like I was saying before, the transformation and the data upload can be time consuming just because of the nature of it. It's way easier to have it automatically come off the systems and be uploaded in real time as opposed to doing it manually. So it's a cost to efficiency. And there was a substantial volume of data that was, we had to deal with it. So at the end of the day, though, valuable as-built records can be acquired when these challenges are overcome, these real-world challenges. So, it is a lot of work, but there is value in the data at the end of the day. So in conclusion about measurement while drilling, the proper equipment setup, personnel training, and definition of measurement while drilling goals are essential to an efficient measurement while drilling program. Thanks, everybody. Appreciate you guys hanging out for this hour and a bit, and I hope everybody learned something.
Yeah, thank you, Jeff. It's such a treat to have something so comprehensive and so understandable from, almost the 101 right into complicated real world examples. So thank you very much for that. So the floor is open for questions and hopefully answers. Please type them into your appropriate chat window. And don't go yet because we'll have a quick wrap up of the IMS committee activities in a few minutes as well. All right, well, I'll throw one out at you, Jeff, which of course we didn't discuss in advance. So hopefully you're up for it. But is there anything on the horizon technology-wise that you're excited about or that you predict might be coming in the next few years on the subject of drilling telemetry or MWD? Or are we already at the cutting edge in DFI, which may be the case?
I can't really talk too much about other project types because I'm more into drilling and grouting. But I do see we're doing things in 3D that we're pretty excited to show, and we've been seeing a lot of value there. And I'm looking forward to possibly seeing that same application of project data being put into other types of projects like cutoff walls or deep deep soil mixing, or jet grouting. I think that the whole industry can then be benefit from the 3D aspect of these new projects. That's the one that's been, I think, a game changer and will continue to be a big game changer in the future.
Good answer. Hey, advance the slides if you will. Let's talk a little bit about what's coming up in DFI, and if anyone thinks of any questions while we're speaking, please type them into the chat box. So if you did register for a professional development certificate, you'll receive it after this. And hopefully you found this webinar via some DFI channel. And you should know to go to DFI.org, especially our community page for the IMS committee to find out about upcoming activities and webinars. Hey, there was one question that just came in. From Matt. He wants to know, where should someone go to learn about incorporating information management systems for their company or on their project? I could certainly speak to that, but Jeff, if you want to comment first, it's up to you.
I think the very first stop would be the Information Management Committee and our documents and specs and things like that. I think that would be a great place to start. And if you're part of the DFI, I encourage you to come to some of our meetings and learn about more.
Absolutely. So on that, skip to the last slide, if you would. We'll come back to the webinars. But I want to make everyone aware, actually the previous one, I think that lists are no, somewhere in there. It's not the end. One more, there you go. Yeah. Our primary work product over the past few years, something of which we're extremely proud, is the official DFI information management system specifications, the data management guide specification, also known as. This is a free downloadable document that has project specs that can be immediately applied to any upcoming project that has even the most minimal of data collected. So you don't need to spend a ton of money developing specifications or get scared that your project is too small to have good quality data. These specs are based on similar version from the U.S. Army Corps of Engineers, but they've been highly edited to remove U.S. country-specific language and U.S. federal government-specific language and brought up to date in many other ways. So I encourage you to look at those, and it also serves as a basic 101 type list of the types of data that can be collected on a foundation project and technologies to do so. So we have some upcoming activities that will mention these specs again and much more. We are leading a workshop at the IFCE conference. Yeah, it's both of those slides, so you can pick one. In Dallas in May. That's the first day of that conference, and the results of the panel discussion associated with that event will be repackaged as another webinar on Tuesday, August 13th. So hope to see many of you there. And if you are not already a member, please consider joining the Information Management Systems Committee. We talk about this sort of thing and so much more. We have a series of Teams channels for discussions, webinars, workshops, and discussions at conferences. And the upcoming mid-year committee week is in April, and specifically our committee meeting for the information management system is April 23rd at 2:30 p.m. Eastern Time. You do not need to be a member of the committee or even a formal member of DFI to join our committee meeting in April. So it's a great chance to come in with no commitment, no paperwork, and see what we're all about. Feel free to look at dfi.org or contact one of us for more information on that. I haven't seen any new questions come in. Feel free to pose a question on the DFI IMS committee or anything you've heard about today. We'll stick around for a few minutes. Otherwise, good luck with the rest of your week and happy data management.
Thanks, everybody. I appreciate it.
Jeff.